This is day 17 of Advent of Cyber 2023, and this challenge is called Clumsy Crucible. The lava starts flowing rapidly once the lava production facility is operational. As you leave, the reindeer offers you a parachute, allowing you to quickly reach Gear Island. As you descend, your bird's eye view of Gear Island reveals why you had trouble finding anyone on your way up. Half of Gear Island is empty, but the half below you is a giant factory city. You land near the gradually filling pool of lava at the base of your new lava pool. Lava ducts will eventually carry the lava throughout the city, but to make use of it immediately, elves are loading it into large crucibles on wheels. The crucibles are top-heavy and pushed by hand. Unfortunately, the crucibles become very difficult to steer at higher speeds, and so it can be hard to go in a straight line for very long. To get Desert Island the machine parts, it needs, as soon as possible, you'll need to find the best way to get the crucible from the lava pool to the machine parts factory. To do this, you need to minimize heat loss while choosing a route that doesn't require the crucible to go in a straight line for too long. Fortunately, the elves here have a map, the puzzle input, that uses traffic patterns, ambient temperature, and hundreds of other parameters to calculate exactly how much heat loss can be expected for a crucible entering any particular city block. So for example, this is the input. Each city block is marked by a single digit that represents the amount of heat loss if the crucible enters that block. Starting point, the lava pool, is the top left city block. The destination, the machine parts factory, is the bottom right city block. Because you already start in the top left block, you don't incur the block's heat loss unless you leave that block and then return to it. Because it is difficult to keep the top heavy crucible going in a straight line for very long, it can move at most 3 blocks in a single direction before it must turn 90 degrees left or right. The crucibles also can't reverse direction. After entering each city block, you may only turn left, continue straight, or turn right. One way to minimize heat loss is this path. So it starts here, that goes 1, 2, then goes down, then goes this way, then goes up, and it moves along like that. And that is apparently the path which has the least heat loss. And this path never moves more than 3 consecutive blocks in the same direction, and incurs a heat loss of only 102. Directing the crucible from the lava pool to the machine parts factory, but not moving more than 3 consecutive blocks in the same direction, what is the least heat loss it can occur? Okay, so we'll start off copying that to here, and we're going to be needing a function which we would repeatedly run, I think, to find the direction we want to go. Or is that what we need? So we've got our map, or the grid. So initially, I'm not too certain how to approach this, so I guess I'll just chip away at things that I know are needed, and hopefully I can find stuff out. So just to make it easier for us, we'll create constant variables for the directions that we need to go. So let's say up, this is -1, 0. Then we'll just do all the other directions. So down is 1, left is 0, -1, and then right is 0. Oh, I did 1 instead of -1. So one thing that I've done throughout is try to keep this as like XY, where this is X and then this is Y, but because of how the grid is set up, this is Y and then this is X, but I keep confusing myself when I do XY, so I'll just keep it like that. So I can use index 0, then index 1. And I guess I need to create start off with the function path find, and what's going to get passed into this. So we'll pass in the grid. Do we want to do it so, yeah, I'm not too sure, like the approach, like could be a brute force one where it's like you start here and then you go right, you go down, then on this one, or I guess you go right, then right down, just every possible combination, but I feel like that might not be super efficient. Actually, we'll pass in the grid, we'll pass in coord, we'll pass in direction, and then previous. Actually, is there a certain direction we have to go for this? I guess if we just make it right, it either goes straight or it turns, so that doesn't really matter. So what do we want to do for that? Okay, so what's the number? It's the numbers that are in here. Make this proof chords. Make that equal an empty thing. So I guess return pathfind. So I'll pass in grid 0, 0, and this is the current direction, and do it like that. And we'll also add in total. Actually, looking at this, I don't know if it's needed, because we can do something like, say, turn left, turn right, and this will be equals, so how do we want to do that? So basically you can flip it. So let's say we're going left. If we then turn left, we'll be going down. If we turn right, we'll be going up. So basically, if this is 0, then it's these two, or if this is 0, it's these two. I guess that's a good way to put it. If direction 0 equals 0, just do direction 1 equals up and direction 2 equals down, else this will be left, right. Then we're going to create a totals list. So we're going to be running it through like going up, current direction, direction 1, direction 2, and then that will be added to this, and then we'll return the smallest one. So return min totals. Then I guess what we'll do, if coord 0 plus direction 0 is greater than equal to 0 or less than length of grid, no, it should be and, then we need to do and the exact same thing, coord 1 plus 1 greater than 0 and 1 greater than length of the row. Then we do prev coords dot append, oh actually no, we need to do new coords equals prev coords dot copy, new coords dot append grid this plus this, then this plus this. Okay, so no, wait, no, that's adding the value. This should be adding this coord into here. Oh no, previous coords, we should be adding the one at the moment into here. But then what we should be doing, total plus equals the grid. So now I've got that, and then it'll be totals dot append path find grid new coords. Okay, no, that should be this. Then we are passing in prev coords, or I guess this one is new coords, and then total. Although I guess I should add right here, if coord 0 equals length of grid minus 1 and coord 1 equals length of grid 0 minus 1, return total. And I guess looking at this, we should also, what should we do? We should also pass for a minimum value. Min found, start off as none. So basically min found would be like, okay, I've gone to the end for the first time, then we go back, then like pass it forward, values. I guess if min found is not none and min found is less than total, I guess just return total. And maybe we should actually just put min found in here as well. And the min found should be min of this. And just so we don't have to copy and paste this, we'll do for dir in direction 1, direction 2, and we'll do that. So get rid of direction with dir. I got no clue if this is going to work. Let's just run it and see what happens. Okay, got error line 32. Okay, I should probably change these to int. Now run it. Line 29, what's up with this? Unsupported operand type for plus, int and tuple. What's wrong with that? Okay, I guess print coord and dir. Okay, so I somehow messed that up. What's wrong with dir is like these. What's wrong? How did that happen? Let's do coord direction 1, direction 2. Okay, that prints out fine. Where did this happen? 0, 0. Right. How can the direction be 0, 0? Guess we should try doing this. I don't know. Yeah, we'll do that. And just comment it like that. Why isn't that working? To its direction. It's getting here. And we're passing this. And we're passing that. That's this. Okay, we're doing next coord equals this. And next coord 0. Next coord 1. Then let's print next coord. Oops. I should put next coord there. But I also didn't include direction, so that might be it. Okay, that might have been the issue. Okay, maximum depth exceeded. So let's go back to the previous one where we've got that code, and we will increase the recursion limit. and I'll see what that does. Something I just realized, we haven't done the prevent 3 same directions in a row. Oh, and I've realized that there's a chance that this doesn't work, because it might be that you need to go back onto a previous one. Okay, we'll have to add another one in here. If prev coords, if the length of prev coords is greater equal to 2, and prev coords -2 does not equal coord 0 minus direction 0 times 2, and it would be this. So if we're going, say, down, and we start at 0, 0, goes down 1, 0, then 2, 0. So we'll be looking at that, I think. Wait, I'm not even using previous coords for anything. I guess I am using it now, but sure, we'll do that. Let's try run it and see if it works. Lesson between none type. What is that error here? What? How is none getting to that? What is going on? Returning total, which is a number. Oh, that's this. Okay, we're just gonna put in really high number and use that. Okay, sure. Why isn't a number being added to it? Actually, why is it even returning? Is it happening in here? No. I guess total doesn't exist there. Yeah, but it's not happening there. Is it happening here? No. Okay, I guess let's print total and see what's happening. Okay, so it is running. So it runs that many times, but where's it returning? So it's never reaching this, but then why does it return? It should be continuing to go through. Guess what coord are we at when it returns? Why is it returning at that? It should just go down. Okay, it's a better thing that we should look at. Print coord. See what it's doing. So it starts off going all the way to the right. Then it goes... wait. It goes all the way to the right. Well, it goes down. And it goes this way. Oh my god, it's going to be going in a circle. Although that doesn't answer why it's just exiting. Like, why is it doing that? Actually, maybe let's grab this as well. Put that up here. And we do if next coord in prev coords continue. I don't know, does that do anything? No, exact same. Just for some reason it exits straight away. Is this the problem? The next coord? Okay, so this part kind of seems to be working. What about this section? Could that happen? That works once. Is it possible to have this wrong? So if this is 0, if we're going left, we can only go down or up. Doing this, we can only go up or down, that's fine. Maybe I'll just change that to its own condition as well. Continue. Then print next coord. Oh right, that should be in there. But why is this going in a straight line? We clearly said to do this. Look at this. Oh, we've got this thing right here. Should be dir. So I don't know if that's a problem, but... still just goes in one direction. I mean, it looks like it almost worked. Like it got to the end. Wait, did that work? Did it? Oh no, that should be in here. And let's remove this from there because that's no longer needed. But what? I don't know what's going on with this. Like it's just returning for no reason. Like it just makes no sense. Like it's not returning. It never returns here. Never returns here. But then for some reason, it just returns here. I don't know. Let's print coord here. See what it does. Maybe try print totals below here. Where's it getting this? Why is it returning this number? Did I put the wrong condition in here maybe? Right, that's not at the very end. Okay, let's remove that. What's the pattern it's doing? Ah, I just noticed down here we're passing direction. It should be dir. Okay. Well, it's doing the same thing still. Have I forgotten that anywhere else? No, that is fine. But why is it doing this? It's going all the way to the end and then just does nothing. Like, why aren't these ones going down? Like, is it going to actually run those? Okay, I guess we also need to else print, do print 1, then these 2, that should be here, and we'll also print that here. Okay, this is fair enough, but why is this going on in here? Okay, that makes sense, but it still just goes in a straight line anyway. So it's never doing this. So yep, you can clearly see these are going in a row. Oh my, I've done it the wrong way. It should be equals. Okay, there we go. That seems more like it. Let's get rid of these prints. Let's have a print in there though, just so we can see. Okay, it's starting to go through, although that is taking a long time. So if we did this with the real input, it's going to take even longer. So with how long that was taking, this is definitely not going to work. So I need to rethink how I'm doing this. It's probably more efficient ways to do this. Because the way that it's currently working, it's currently just like trying to brute force literally every possible type of way to get to the end, and that's not going to work, so we need to rethink that. I feel like if we change how this function works, like maybe it doesn't need to be a recursive function, we just run it once and then inside here we do stuff. So I guess to begin with, let's just remove all this and we're going to kind of start over. So we'll do visited as a set. This is going to be the coordinates that we've already gone to, and then we're going to have a list in here of the places that we need to go to. So this will be called directions to go. Maybe there's a better name for that, but I'll do it as that. This will initially equal so we'll start off with 0, 0, and we will need to go right, and then this will have a counter of 1 as we've gone in that direction once, and then it'll be 2 more. And actually we can change that so it's just like this, and then basically same thing again, but it's going to be down. So we've now going to have a list of places that have already been, then directions that need to be gone, and then we'll do basically just iterate over this, and we're going to be, as we're going through, adding new directions into this list and figuring it out that way. So while length of directions to go is greater than 0. Actually, something I just thought of looking at this, we're not actually recording the totals within this, so we'll also add total to here and here. So now when we're going through this will be, okay, what do we want to do for this? So we'll do total y x direction and total direction equals directions to go 0. And what we'll do, so for visited, instead of it being just the coordinates, we will do what do we want in there? So we don't need total, but we'll do y x direction total direction. So if this is in visited, actually looking at this should be like a pop, so change that to dot pop. So if it's in visited, continue, else visited dot add this into there, or it should be like that. Okay, so we've now sorted out visited. If it's already been there, it's going to continue, and if it's not, we're adding it. And I guess that, like, including the direction and total direction there is good, because like if we've already been down that path, then we've probably, like, we're just doing the exact same thing before, and if we're doing the exact same thing as before, then we've probably already done more steps to get to there. But I mean, we'll have to see how that works. So next thing to do is create the new coordinates. So new coords will do equals y plus direction 0, and then x plus direction 1. Then we can probably, so min found, we'll remove that code, and we want this code here. I'm just going to copy it to here for now, probably going to change a bunch of it. So new coords, I guess we can just call it coord, so we're just throwing x1 like that, so coord is this. Although now we don't need to do the plus because we've already done that. So if this is greater or equal to y, actually we're gonna do the opposite, because just so we can get rid of things quicker. So do continue there. So we now know it's outside of the grid, so we don't want to be doing that. So continue. So we know that, because we know that this is outside of it, we can go to our total value plus equals grid coord 0 cohort 1. So we now got our total value. I guess something that we can do to get out of the way. Target equals grid, length of grid -1, then length of grid 0 -1, just so we don't have to keep typing that out because it gets annoying. So got our target, got total. I guess something we should also check, let's add a max. So we'll change this target, let's put that here, and we'll do max, what do we call it, total direction equals 3, and we can do, if it's in there then continue, if total direction equals max total direction, continue. So we also do that. So now they've got total. And then next is a similar thing to what we did before. So for grab this, let's grab that. And what are we looking for? So now down to total, direction 0, and then we'll also do this, directions like that. And then we'll do for direction in directions, we will do directions to go dot append. Actually, we'll do this one first. And what are we adding to it? Let's just copy this. So right, that should be direction. Then it would be total direction +1. This is total. Then y is plus direction 0. Then x plus direction 1, and then we'll do same thing in here, but now it will be dir, and this will be just 1. So I think none of that's needed. Let's get rid of this now. So I guess what we're also missing is so I've got the next cohort, I've got total. But what we should also have is if cohort 0 equals target 0 and cohort 1 equals target 1. So maybe return total, but this needs to, how we're handling the direction to go needs to change. What we need is to prioritize the directions that are in there. So the best way to do that would, I think, be to look at the lowest total and calculate that one. But how would we do that? Okay, so I decided to use ChatGPT to figure out how to do this because I'm not really sure. I feel like I'm getting a bit too deep into this, I don't know. But it says there's a library called heapq, so import heapq. Okay, so that does exist. And so what it says, first things first, you got your list, then it's saying to do heapq dot heapify, and then my list. Oh, my list. That's in the example it says my list, but this directions to go. And then instead of doing pop, we would do heapq dot heap pop, and that should retrieve. So based on this first value here, the total, it's going to retrieve the one with the lowest number, and having the lowest number is what we want, because if it's going to keep processing the lowest number one. So that means if it ever gets to the very end, that's going to be the lowest number one possible to get there. So that's one we want. And then when we add to the list, so here it should be heapq dot heap push. It will then be the original list, and then the new item, like that. And then we need to do the same thing down here. So got that, paste there, and I think that'll work. So I guess let's go through this. We've got our directions to go. Sure, we'll do that. What's greater than 0? I'm gonna grab the one with the lowest, which is this one. Oh, either of them really, but we'll say this one. If it's in visited, which is not, it will continue. If it's reached a total direction, which is not, it will continue. grab the new coordinates. If the new coordinates are outside of the bounds of the grid, we continue. And when I say continue, I mean we go back to the top and grab the next one. So if it's not outside, we increase our total. If the coordinates matches our target, we return total, because we've now got the lowest possible total to get to the end. If not, then grabbing our directions for the next iteration. So directions is that. We heat push. So we're continuing the previous direction, and then this. So let's remove that. And what do I need? I just need to pass in the grid. So, okay, we haven't tested running this yet. I've been kind of just focused on trying to figure something out, but let's run it, see if it works. Set object is not callable. Okay, visited. Oh, okay, so right here. That's the problem. Now run it. List index out of range. Okay, let's print code to figure out what's wrong with that. Okay, well, did we do the opposite? Okay, I got no idea how we did that, but if okay, we kept the old ands instead of the ors. That's what happened there. So now, okay, still getting out of range. Okay, we've got 13. That's because we forgot the equal sign there. Now we'll run that, and it returned nothing, which is great. Now let's put that chord back and see what it's doing. So it ran a lot, but how did it get to nothing? I guess let's print directions to go or something. Okay, I don't think that went through. Although it's gone over 102, so maybe, I don't know. Get rid of that print, and then we'll do if total equals 102, print, I guess let's just print all this. So that should be this. Yep. So we've gone to 102, but we've never reached the target. Do we do the wrong thing for target? 12, 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, okay, so that's correct. We've probably done a mistake somewhere here. Oh, that seems correct. Let's try this. Just do if either of them is in like range. Like we can see that it gets to here, but then it doesn't do anything. Okay, let's grab this and put it into here. Maybe we've messed something else up. Nope, so there's never a situation where that happens, where it's actually inside the grid. What if we do this? So there are times where it's... Okay, mate, actually that's not the part I was really looking for. I was more thinking this one. So it gets to the very end. But it's not... How does it get to the very end? Like with these? -1. Is there a situation where, let's say, that equals 12 and this one -1, and total direction is less than 3? Does that ever happen? Yeah, so it happens there, but it just doesn't go to the next one. Maybe we should... Let's do if this equals this, or the opposite of that. So -1, and we will print this. And what does that give us? And for the sake of it, we'll also do this. Okay, so what does that give us? I guess we should also print this, just so we can clearly see what's going on. Okay, so those are all 11, 11. Wait, we're doing if this equals 0, and oh, we're doing y and x instead of coord. Coord 0, coord 1. Wait, that is what we should be doing, right? Oh no, wait, no, these should just be coord like this, and then we're giving a new direction. Oh, I'm putting that in the wrong spot. That should be this, right? 113. So that's wrong. Should be 102. So I've definitely messed something up there. Okay, so there's something else done wrong, and I'm not sure what. I don't know. Could it be possible that the issue is with this? Maybe that's... Maybe my math for... maybe the way I've done this just doesn't work. So let's change that to for dir in, up, down, left, right. So basically the only way we can't go is backwards. So if we go up, we can't go down. If we go left, we can't go right. So, okay, what we can do, if this plus this equals 0 and this plus this equals 0, then you can't do it. So for dir in this, if dir 0 plus direction 0 equals 0 equals 0, and these two equals 0, continue. Otherwise, so we need to also look at this. So I guess new total dir equals 1 if dir does not equal direction, else total direction plus 1, then new total dir. So get rid of this. Now let's run that and see if that does anything. Nope, it is the exact same. So I need to keep digging as to what the possible problem is. Actually, something I just realized looking at this, if total direction equals max total, so max total is 3, that doesn't work. So we're starting on 1. We start on 1, then we go 2, 3. It should be, if it's greater than, I think? Ah, okay, so that was what's causing all the issues. That is great to see. Hey, so I guess we can finally grab what the actual input looks like and paste that into here. 928. I really hope that is answered because I've been spending so much time on this. Oh, finally that is part 1 done. So, okay. Now on to part 2. The crucibles of lava simply aren't large enough to provide an adequate supply of lava to the machine parts factory. Instead, the elves are going to upgrade the ultra crucibles. Ultra crucibles are even more difficult to steer than normal crucibles. Not only do they have trouble going in a straight line, but they also have trouble turning. Once an ultra crucible starts moving in a direction, it needs to move a minimum of 4 blocks in that direction before it can turn, or even before it can stop at the end. However, it will eventually start to get wobbly. An ultra crucible can move a maximum of 10 consecutive blocks without turning. In the above example, an ultra crucible could follow this path to minimize heat. So this way, this way, this way, this way. In the above example, an ultra crucible would incur the minimum possible heat loss of 94. Here's another example. So with this one, it would have to go here, here, here. Okay. I need to reread that. So it has to move a minimum of 4 blocks and a maximum of 10. Okay. I think I have a good idea for that. So firstly, min total direction, max total direction. Actually, I will just uppercase it all. And for here, 0, 3, 4, 10. So we'll do that, then we can get rid of this. So it needs to be minimum of that direction. Guess there's a couple things we need to do. So where is target? We will need to also do total direction is greater or equal to min target, min total direction, and this. So that's the first check. Then what we would need to do, we'll need to have a check in here if the min is not greater than the min, if the total is not greater than the min, then it has to do the exact same one. So we'll do if dir equals direction. Actually, if dir does not equal direction and total direction is less than min total direction, continue. Otherwise, it then does that. I think that's the only thing that needs to be changed. Actually, let's cancel that. Go on to the small input. 94. Wait, that... Ooh, got 94, which is what is expected. So maybe... Actually, can just go straight to the proper input. 1104. Oh, I really hope this is the correct one because I've spent too long on this. Oh, yes, and it is the correct answer. So that is day 17 of Advent of Code 2023. If you like this video, make sure to like and subscribe so you can watch me try and complete the rest of these challenges.